Hello everyone, I am Divanshu Kumar and today I will be discussing a problem named Chef Designer Network. This question was of September 2019 of CodeChef. We were given that we have n computers and m cables. With means with these cables we have to connect these computers in a manner such that there is at least one way of communication between any two computers, means any two computers are interconnected, and also each computer can be also interconnected to itself through a cable, right? uh, the cables are bidirectional, right? So let's just consider uh, three cables, right? And here we have three computers and three cables here, so this is one of the possible arrangement. And there was a concept called defined how many cables are connected to a system, right? That we have to minimize. Suppose in this system, with each computer there are two cables connected. In this there are two cables connected. In this there is only one cable connected, and again in this two cables are connected. So data consumption factor of this system will be 2. That is maximum of cables connected to any of the system, and any interconnection is counted as only one, right? uh, okay, so this was the question, right? And we were given t is the number of test cases with that is less than 5 into 10 raised to power 5, and n is less than 10 raised to power 6. M is the number of cables that is less than 10 raised to power 50, right? So we were given this question. So if you have not solved this question yet, I would suggest to give it a try. Pause the video now and try this video, right? Now I will start discussing the solution, right? So basically if you see this question, basically there can be multiple arrangements how you connect the cables, but the minimum possible way in which you can connect is something that you have to come up with, how you will connect m cables through n computers such that minimum is defined, right? So basically if you see, if there are n minus 1 cable, the shortest way to connect them is like this, and then you will have a data consumption factor of 2, because like each system, at least one system will have two connections, right? And then let's just say there are n connections all still, then I can still add one cable like this, and still each of the computer has only two connections still. So if the cables is equal to n, or n n n minus 1, then answer is 2, right? So, or then if you connect other otherwise, right, if there are more cables, then how you will connect, right? Then there is one possibility of interconnections, right? Then you have minimum uh, for another n, right? If I connect like this, and then I have one interconnection to each one, such way the minimum data consumption is 3. So if m is greater than n, and then m is less than twice of n, right? Less than equal to twice of n, then you will have a factor of this, a minimum data connection of this. Also, if you have a case something like if you have n computers and you have uh, n plus 2 cables, sorry, n plus 1 cables, right? Then you can have, instead of going with this one, you can have two interconnections at the end, and still you will have a data consumption factor of only 2 with n plus 1 cables. So again, this is a side case. If m equal to n plus 1, then answer will be 2. So here basically in this question you have to come up with the cases which you can think of for minimal connectivity, right? Then after this, after 2n is an important case, right? Then how you will connect basically, if so basically if you see the connections that will be made, uh, we have these connections, right? I will just draw the basic 2n connections which you will have for sure, right? These are the basic connections which you are bound to have. Then you can have these connections and this connection. Then you will have, still you have each node connected, each node with the data connection factor of 1, 2, 3, 4. You can check at any node, you will have a data connection factor of only 4. So basically what I did is connected uh, alternate systems, right? So but you have more than, let's just say 6, 7, 8. So then you will have, so then you will interconnect the systems, but in a manner, sorry, this will be connected with this one. Now here if you don't connect this system again, right, because then it will have another data consumption to this, right? So basically then you will just simply connect this one. Only one more is possible, right? So basically what I'm doing is breaking into chunks of 4, right? In 4 I can have 2 connections. In that manner I'm doing, right? So basically if you, I will just walk you through the code, that will be easier for me to explain all the cases. The code is going to be a bit long, so don't be frightened, right? It just contains all the corner cases I just thought of, right, during the contest, right? So yeah, and one more thing, the code can be optimized further, but this code has a lot of corner cases, means like covers a lot of corner case with some if else statements, right? So you can write a code which basically covers all those cases, but at that, this is a code I came up with in the contest, right? So but still let's see this code, right? So if n equal to 1, right, means I have one computer, right? Then if the cables are 0, then I will have 0. If the cable is 1, then my data connectivity factor is 1. If I have more than 1, right, if you see one computer only, and at max I can do is this, right? If I have more than this, I cannot connect it, right? So answer will be -1. Okay. And then if the, also one more thing to what will be the maximum is, if m is less than n minus 1, you cannot connect all the systems, right, such that all the systems are interconnected to each other. So m should be at least n minus 1, okay, and m should not be greater than n into n plus 1 by 2. Why so? Because that is sum of n natural numbers. So if you see any node here, let me just take one simple example. So here it can connect to 1, 2, 3, right? And this can again connect to these two, right? And this can again connect to only one. So basically what is the ongoing fashion here? That is n minus 1 plus n minus 2 plus n minus 3 dot 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 till 1, right? So basically if you see this, that is nothing but the sum of first n minus 1 numbers, right? So sum of first n minus 1 numbers is uh, right, let me just erase it a bit, right? Okay, yeah, so sum of first x numbers is x into x plus 1 by 2, right? Why I wrote 2, man? X plus 1 by 2, right here. So for sum of first n minus 1, because here it is n minus 1, n minus 2 till 1, right? So n minus 1 into n minus 1 plus 1 by 2, right? This will give me n minus 1 into n by 2. But again you consider one factor here, is like each node also has an interconnection, so you have n additional connections, right? So basically n minus 1 into n by 2 plus n equal to n square minus n plus twice of n by 2 equal to n square plus n, that is nothing but by 2 here, n into n plus 1 by 2. So this is the maximum number of connections you can have. Beyond this you cannot connect any, there is no possibility, because we were mentioned between any two computers there can be only one connections, right? So based on that formula I derived this, right? So let's go again here. So if it is greater, then also answer will be -1, right? Else if n equal to 2, okay, this one I wrote explicit, right? This you don't need to write. For 2 I wrote, I don't know why I wrote at that constant time. I thought maybe it may come as a corner case, so I just wrote it. But yeah, let's go through it. If n is equal to 2 and m equal to 1, right, means like there are two two computers and there is one cable, right? So there the data consumption factor will be 1, right? Okay. Or if it is 2 or 3, so basically 2 or 3, then the data consumption factor will be 2, right? So this was the case. I thought maybe because I came up with this, I thought it will become a corner case, because if I connect this, then this is wrong, right? Because earlier I explained you I will be connecting first and last one, right? So that's why I wrote it separately. You don't need to write it separately, right? But yeah, it was my contest code, right? So, and then also I told you this case, right? If m equal to n plus 1, then the answer will be 2. This case basically, this one. If m equal to n plus 1, right? Here I wrote, right? So answer will be 2. And then, so answer will be 2, right? If m is less than equal to n, elsewise, if it is great, if it is, so basically this is nothing but equal to n only, right? So because if it is less than n minus 1, the answer will be -1. So basically this is m equal to n, right? So your answer will be 2 then, right? If m is less than equal to 2n, so basically then answer is 3, the including the self loops and all, including the self loop and last ones, right? Including this all, then the answer is 3. Okay. Else if n mod 2 equal to 0, means basically if the number of computers are even, right, then p equal to n by 2. Basically I'm just considering another number, means half of that computers, right? So because, and then r equal to m minus twice into n. So basically if you see here this case, so basically in the next step, after twice n of cables, what I'm able to connect, half, exactly half of the computers I will be able to connect, right, alternately, right? So basically in that, for that case, I'm subtracting this. Then if how many cables are still left, right, after twice and after subtracting the twice and cables, means the initial cables, right, the self connection and adjacent ones and first and last, after subtracting this, how many cables are left? if if p can exactly divide r, then basically it is 3 plus r by p. How many two connections I can make, right? If you see here, right, let me just take another example. Let me just take 8 nodes, 4, 5, 6, 7, 8. Right here I can have this and the self connections, right? And then in the next step I will have this, this, this and this. So here you can see I had 4 connections in the next time, right? And again if I have to go once more, right, then I will go with this, this, this and this. So basically if you see, I can go on, I can add two cables each time, right? Or basically I will just color the next one for you in a different color, so as it is easier to view. Let me just take this uh, green color. Okay. Right, right. So if you just see, in the next step I had this and this interconnection and this interconnection. So basically next step also I had 4. So basically this 4 cycle will continue till I reach n plus 1 into n by 2, right? That is the case. That is the most optimal way to connect. Then basically, then just I'm doing that 3 was the base uh, case when I had only interconnections, and then I'm just adding how many extra cables I connected, that is R by P, right? Else the answer will be if I cannot divide this, right? So basically what I'm saying is, maybe after this, right, I had like suppose 9 cables left, right? Then also my answer will be and 3 was the base case, right? Then I added 3, suppose 9 are left after 2n cables. Suppose answer was this, suppose the m was this, right? So I subtracted twice n and I am left with 9, right? And 9 by 4, right? So in integers this will give me 2, right? But basically this is supposed to add one more, right? If I just go by this logic, I will have a data factor of 5, right? But I should have, this is 4 data factor, 5 data factor, 6 data factor, but 9 lies in this range, right? So basically I should have plus 1, right? So it should be plus 1. So if it is not equal to 0, if means like if p cannot divide r completely, then I will have 3 plus 1, 4 by 4 plus r by p, right? Else if n is odd, right, if n is odd, still I'm taking p equal to n by 2, that is the connections I can make at max, right? And then I'm checking this, right? So now let's see. So basically if you see the for the odd case here, for odd case, for explaining odd case I have to explain you a bit further. Like let's just say 7 nodes, 3 4 5 6 7, right? Interconnect, normal connections, and then first and last one, and then interconnections, right? These are the first 2n nodes, first 2n cables, right? Then after this I can have one this, one of these, and one of these. So in next step I had 3, okay, 3 connections, 3 cables I added more, okay. For this 2n my uh, data cost was 5, and here I have 4, okay. In the next one I will use another color, right? And then what I can do is I can connect these, and then I can connect, sorry, let's just say I connected these, so I will just write down first the data cost for each of you, and then I will connect. Here I had 4, here also 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 I had 4, here I had 3, and here I had 4, right? So first connection I will make from this, let's just say to this, right? Then here the data connection cost will be 4, here it will be 5, right? And then I will connect, let's just say these two, right? Here then it will be 5, also it will be 5, and then through this I'll connect one more, let's just say this one. uh, uh, so basically what I can do, right, this is there, this is there, right? Okay, yeah, yeah, right, sorry, this. So here also data cost is 5, now here also data cost is 5. Now only two nodes remaining are these and these, right? So again I will connect these, again I have data cost 5. So basically if you see I connected 1 2 3 and 4 cables in the next step. So and then again I had 4 cables, right, for data cost 5. So basically if you see this, 3 plus 4 I added total 7 cables, right? Now this cycle continues even further, 3 4 again I will have, 3 4 again I will have. So basically what I did is club these two and I made it one together n, right? So basically if you see here, if it is odd, right, then here I did uh, now I'm doing by 2, and here I'm checking if it is divisible by n, right? Because here if you see, that is n by 2 and n by 2 plus 1, right? So basically that is nothing but n only for odd numbers, right? So that is only the case, and then I had two steps clubbed together, right? So I'm checking if r mod n is equal to 0, then 3 plus 2 into r by n. See here, because I clubbed two steps, so I multiplied by 2 here, right? Now the final case is, if that is less than, if that is not equal to 0, if r mod n is not equal to 0, then there can be two cases. If r mod n is less than p and it is greater than p, right? If it is less than p, then it should be uh, 1 should be only added right here, because if you see 3 4 3 and 4, right? So if it is less than 3, then only one extra one extra data cost is added. But if it is greater than 4, suppose here it was till here it is 7, then again 10, then suppose it was 12, then 12 lies in this range, right? Then two cable should be added. So 3 plus 2 5, 5 plus twice into r by n, right? So that should be all the cases. Yeah, this question was all about coming up with this pattern. uh, I'm sorry for the long code. You could come up with a shorter code which covers all the cases, but just it was my point to show the code I came up during a contest, right? So that's why I showed you this code. If you have any doubts still, then post it in the comment section below, and do subscribe to my channel. And yeah, happy coding. Thank you.